AI is moving past single number scores and one-shot generation. The real shift is towards systems that remember context more intelligently, preserve consistency after edits, and even blur the line between discrete decision trees and continuous generative flows. That matters because the next wave of models won't just be bigger, they'll be more controllable, more reliable, and cheaper to deploy. Keep watching, because the interesting part is how these ideas turn into practical gains in evaluation, video editing, and tabular generation. Let's explore the first paper, Beyond Scalar Rewards by Internalizing Reasoning into Score Distributions. Z-Reward, from Alibaba Group's Z-Image team and Nankai University, reframes visual reward modeling as a reasoning condition score distribution instead of a single scalar. The paper uses Quen 3527b as a teacher and Quen 359b as a student, with group-wise direct score optimization, GDSO, to train the teacher on point-wise score calibration and same prompt score gap supervision, then reasoning internalized score distillation, RISD, to transfer the teacher's distributional judgment into a compact deployable model that no longer emits reasoning chains at inference time. On the internally annotated benchmark, the 27B GDSO teacher reaches 89.6% human preference accuracy and 0.762 PLCC, outperforming SFT, Reward Dance, and GRPO, while the 9B RISD student reaches 88.6% human preference accuracy and 0.7391 PLCC, closely matching the larger teacher and beating the OPD baseline. The annotation scheme itself is fine-grained, using 4 dimensions: text, image, alignment, realism, aesthetics, and physical plausibility, scored on a 9-level half-point scale from 1 to 5. In text-to-image optimization, the deployed Z-reward signal is differentiable through score expectations and yields a 41.3% net human preference improvement over the SFT baseline, showing that internalized reasoning can serve as both a calibrated evaluator and an effective optimization objective. Let's explore the second paper, PermaVid Consistent Video Generation Across Edits via Disentangled Context Memory. PermaVid, developed by researchers from Shanghai Jiao Tong University, Stanford University, Nanyang Technological University, the Chinese University of Hong Kong, and the Shanghai Innovation Institute, tackles a failure mode in memory-based video generation. After an edit, older context becomes stale and causes the model to revert to pre-edit content. The core idea is to disentangle spatial context into an RGB memory for semantic appearance and a depth memory for geometric structure, then update and retrieve these banks differently for global edits, which invalidate all RGB context, and local edits, which only invalidate overlapping regions. Built on WAN 2, 114b with a VACE initialized context branch, the system fuses mixed modality references through a DIT video generator and trains in 2 stages on SpatialVid and the new UEMEM dataset. UEMEM contains 4K long videos with 1,000 frames each across 100 Unreal Engine scenes, captured with revisiting trajectories and 6 DOF poses. On a 200 image benchmark with complex revisiting camera paths, PermaVid achieves the best global edit scores, including 22.84 PSNR, 0.8703 SSIM, 0,210 LPIPS, and 12.7.8 clip vid, and also leads local edit evaluation with 22.332 PSNR, 0.8622 SSIM, 0.2369 LPIPS, and 0.8544 vbench avg. The paper's ablation shows that removing disentangled context memory causes outdated RGB reuse and progressive semantic inconsistency, while the proposed retrieval overhead remains only at the millisecond level. Let's explore the third paper, Trees to Flows and Back Unifying Decision Trees and Diffusion Models. In Trees to Flows and Back, Unifying Decision Trees and Diffusion Models, Sai Niranjan Ramachandran and Suvrit Sra from the Technical University of Munich and MCML argue that hierarchical decision trees and diffusion models are 2 limits of the same process. A tree induces a deterministic probability flow ODE through dyadic refinement, while a suitable diffusion process induces a canonical dendrogram via moment-based merger times. They package this equivalence as global trajectory score matching, showing that greedy gradient boosting is asymptotically optimal for a discrete trajectory matching objective, and that standard diffusion training appears as a continuous version of the same loss. The paper's 2 concrete algorithms are TreFlow, which conditions conditional flow matching on tree path encodings and reaches the highest TSTR accuracy on 3 of 5 tabular benchmarks, the lowest Wasserstein distance on 4 of 5, and the lowest correlation error on 3 of 5, while running 2 times faster than TabDDPM and DSM tree, which distills full decision paths into a neural network and matches teacher performance within 2% on 4 of 5 datasets, exceeding the teacher by 3.7% on heart disease. On tabular generation, Treflo reports 0.981 TSTR accuracy on wine with 1.816 runtime versus 3.901 for TabDDPM, and on distillation, DSM tree reaches 75.31% accuracy on heart disease versus 71.6% for the base tree. That's a wrap on today's AI paper highlights. Thanks for watching.